Hello, today we're going to be discussing RStudio. Myself, Cole Dean, as well as Ricky Castillo and Nate Ting are going to be working through a few different things that you can do with RStudio. So first here, we're going to be discussing how you need to organize your data. You can import data from a couple of different sources, but the way we're going to be doing it today is through Excel. And with Excel, you just need to make sure that you've written it right. And for this specific problem that we're doing, you're going to need to have several different columns. Make sure that you have headers because we can reference those later. And then for the first one, you can put dates. That can be used for sorting them into different quarters, which is what we did for our specific one, so we can have multiple maps. Countries, which is relevant for box plots, but it's not actually going to help you for the mapping. Cases as well as deaths, and these are going to be your vectors that are actually the data that we're looking to represent. And then something that's very important is longitude and latitude, and Ricky actually did a great job going through by hand and doing all of this, because you can't actually, with the mapping software that we used, just refer to the countries and get it to plot in the specific countries. You have to use longitude and latitude points, so that all has to be done by hand if you want to recreate this. And then we're going to move on to how we did the specific histograms. For histograms, this is a relatively simple function that you can use. But what we did here was we used those data sheets that we created in Excel, loaded them into the environment for RStudio, and then you can reference those using your histogram, so you don't actually have to write out the entire vector. With that, we also did our bar plots. Again, very, very similar. We'll discuss all those more simple graphs in a little bit. As well as box plots, and here is more of the actual scripting for what you might write. Again, these are only examples. We've linked down the complete R file below. So, on this first plot, it shows cases on the left as well as frequency on the bottom. Again, some of these are more relevant than others. And the next one shows the cases on a latter date. And the next one just gives you a rough estimate with a bar chart of how many cases each specific country has. And this isn't too representative because you can't really tell how many cases the smaller countries have. However, it will give you a rough estimate of where the spread is mainly concentrated on the countries, but it's not adjusted for the geographic size. Moving on, again, this is just another example. So recoveries, just a different vector, but basically showing it the same way. And this is a box plot, and these are relevant because it shows you the actual spread over the iterative months. So if you look data 1, 2, 3, 4, so those are over the actual quarters that we discussed about, that we broke apart the first part of the outbreak, second, third, fourth part of the outbreak. And the recoveries, again, showing it the exact same way, but just with a different vector and different data. And we did try to include looping on this. For example, we were going to use for looping. We were going to embed our mapping so that we could have a flipbook style loop that would take you through all of the cases as it evolved through the epidemic. However, this wasn't actually available because we were going to use the delay function, and that was defunct in a version a little while ago of R, and we were trying to recreate that, but just couldn't do it. So looping is a great thing, but we couldn't get it to work for our exact example. And then moving on, Nate is going to take you in a little bit about how you might actually create these specific maps. And in doing so, it's very, very helpful because it gives you the SAM data, but across the geographic size. So if you have a smaller country, it'll show you the representative hit that it took, as well as larger countries like China and stuff like that. It's a really, really cool algorithm that you can use just to make your R files look a little bit more polished, as well as show data to a group of people in a more useful way. And humans are visual learners. We don't really understand, lines of code. However, when it does output these really cool graphics, they're really, really helpful for understanding the breadth of a specific pandemic, as well as other things.
Hello, my name is Nathan Ting. I was responsible for creating the maps in RStudio following the SARS outbreak quarter by quarter. To do this, I used these packages: our color brewer, which allows me to choose colors; our world map, which is the main package that I ended up using, that essentially allows me to draw maps of the world in R; read Excel, which allows me to read this type of file; cable extra, which I believe is a extension required to have our world map pull specific coordinates, and then Dippler, which allows us to read in the Excel file the latitude and longitude and plot that to a certain point on the map. So here are my libraries, all of the extensions I used up here. So we're going to go through this code line by line. So here I've loaded my map data using read Excel, and then I'm going to head my map data so that I can aggregate it here and name the columns. After I've done that, I want to set my first quarter to join country map data 2, and we're going to keep the default values for that. So then I have my first quarter data set here, and then I have my color palette, and then here is the line of code that will end up plotting the map. So I'm using map country data first quarter, which is right here, and then name column to plot first quarter cases. The width is fixed, and the color palette is simply referencing this line right here. And then numcats, I'm not entirely sure what that does, but it wouldn't work without it. So that would be the first quarter cases. And as you can see, we have a nice heat map of a spectral array showing that China had the heaviest amount of cases in the beginning of the SARS outbreak, but also it had spread to Australia, United States, Canada, etc. For the second set of data, I have a second Excel file. Here I have all of my Excel files. There are 2 of each because I needed to use an XLSM file, while some of my teammates needed to use CSV files. So each of these data sets are the same, simply a different file because we were using different lines of code to read them in R. So here is my directory following to data 2. We'll go through it again. Head the data so that it can be aggregated, name the columns, set it to quarter 2. All of these are second quarter. Same color palette for ease of interpretation. And I missed something. There we go. Second quarter cases. So as you follow, or as we can follow along, it gets worse in China. Also, the Northern American countries have darkened, in Europe as well. So essentially, I end up following this same formula all the way through for each quarter. There's a third quarter. With each block of data, I end up creating a new data set for it that R will reference, so it has all these individually. And then the fourth quarter. There we go. Fourth quarter cases. Things begin to stabilize during the SARS outbreak. In order to do this, the Excel files that we used had to have latitude and longitude, and Ricky put these together, and he ended up using an index to reference each country and then plot the latitude and longitude for each. So a little bit of class knowledge applied to create this, which is pretty cool. So that is essentially my part of the project. I ended up knitting this to a Word file, which is what you will find in the submissions. I had a lot of fun with this, and I will continue to use RStudio for sure for other projects in the future.
And to sum up, I just wanted to discuss some of the things that you'll come across if you review our data sets. One of the reasons why we broke it apart into multiple different Excel files was because that was simply the easiest way to get it to read multiple different maps, and we decided that it'd be cool to show the progression of the outbreak. And the only way we could do that was if we separated these vector values. So that's why it's a little bit of a mess. Hopefully it's not too hard to come through. Again, Nate already discussed why there's 2 different files, CSV and Excel files. Generally, CSV is the standard. However, R for this purpose can use either of them. And for mapping software, there are a bunch of different packages that you can use within R. We would recommend this specific one just because it's the most plug and play. And we found it to be generally pretty easy once you got over the hiccups of a couple of the finicky things with the specific coding and syntax. And we hope you've enjoyed what we've discussed today. I hope you'll go out and try it for yourself. We would all really encourage it, and thank you so much.